Okay, so welcome to this video, which is a follow-up on the calculation that we did on circular motion in our instant calculations videos. You can check the video if you haven't watched that video. Please support our work by subscribing to our channel, Focus College on YouTube. You can also share this video. You can contact me directly for lessons. So let's look at what you have to learn before you can do these calculations properly. So you need to understand the forces that are acting every time you have an object in a circular path. So for an object to go in circles, imagine a trolley, a cart, for you to change its direction so that it can go in circles, you have to apply a force, a net force that pushes it towards the center. So that is a requirement in order for circular motion to take place. So you need to apply a constant net force towards the center of the circle. If you didn't apply that force, then the cart would simply take off in whatever direction in a straight line. So you have to apply that net force towards the center. It's a requirement. Then also you need, for the cart to have an initial velocity, it has to have a velocity, it has to be moving for this to be possible. And this velocity has to be constant. If there wasn't such a velocity, then if you applied a force towards the center, you would simply drag or pull the cart towards yourself. So we need a velocity, a constant net velocity, in order for us to have our circular motion. So those are the two requirements. The net force has to be constant and always pointing towards the center, and there has to be a constant velocity at 90-degree angle to the net force. So these are the two requirements which enable a continuous circular path for your object or particle. So this is important for you to remember. So there's a vocabulary that you must also adopt. Centripetal force here means the net force on the object. It is always pointing towards the center of motion. It's measured in newtons. We have tangential velocity, which is the distance the object moves around the circle over change in time. So this is your total distance right around the circle divided by the time it takes. And the centripetal acceleration here is the acceleration of the object. It points in the same direction as the centripetal force, which is towards the center, and it's measured in meters per square second. So those are the three variables. Another variable there is radius, which is the radius of your circular path. So that is the relationship of those three. Take note, your centripetal force and centripetal acceleration are pointing in the same direction, and your tangential velocity is always tangent to the circular path. Okay, so let's move on and look at one of the common misconceptions about centripetal force. It's not a type of force like your normal force. It is the sum of all the forces that are acting towards the center. So if we are talking about planets orbiting right around the sun, then it's your force of gravity. If it's your car moving in a circular path, that would be your friction. So whatever force is acting towards the center of your circular path is what we call centripetal force. So, and also centripetal acceleration there does not cause your object to increase its speed, but simply changes the direction of your velocity towards the center. So that's the function of your centripetal acceleration. It's not increasing the speed. Remember, we need a constant velocity. Okay, so those are some of the things you need to remember. But in the question that we attempted, we saw that there wasn't a constant velocity because the velocity was being continuously increased. So it got to a point where the frictional force could not hold, and our mass ended up flying off the surface. But here we are saying there has to be a constant velocity. So I urge you to go and see that video and see the differences that I'm talking about here. So here is a specific example. Imagine a person or an object on a circular path on a spinning surface like that. So what enables it to stay are the forces that are balancing out. So we start with the forces in the y direction, that is up and down. We have our gravitational force being balanced out by our normal force. So there's no net movement in the y direction. And also there's no net movement in the x direction, because we have our centripetal force, which is equal to our frictional force. In other words, the frictional force is acting as our centripetal force, the sum total of the forces towards the center. So it's your frictional force, which is your centripetal force in this case. So we can put that in a table to see which forces are balancing out in the x direction and which forces are in the y direction. So we say it here. So there's a formula for you to calculate the force. Remember, the centripetal force is equal to mass times acceleration. So it's the mass of the object times your centripetal acceleration. So we have two expressions for centripetal acceleration. One is tangential velocity squared divided by your radius or distance from the center there. Another one is that you can say angular velocity squared times your radius. So you can say m angular velocity squared times r for centripetal force. So remember, this centripetal force in this case is equal to the frictional force. It is the only force that is holding that person and hence pulling that person towards the center in this case. Okay, so remember, frictional force is equal to our centripetal force, and it can be equated to this expression m v squared over r, or like I said, m angular velocity squared times r. So you can create equations there and manipulate them to find unknowns. All right, so let's expand this a bit and add a bar. So the person is holding onto a bar. So we now have an additional force acting towards the center, or helping the person to stay in the circular path. So we have our frictional force, but we now have something called applied force, which is due to the person holding on to that bar. So these two forces are now representing our centripetal force. So they add up to give us our centripetal force. So those are some of the cases you need to watch out for. Is there an additional force which is helping out the friction? Remember, that must be added to the friction to give you centripetal force. And you can equate those two to expressions representing our centripetal force, such as mv squared over r, or m angular velocity squared times r. So I'll meet you in the next video. I'll meet you in our seminars groups. So subscribe to our channel, share the video, and support our work. See you in the next video.